there are 5 red cars and there are 3 blue cars. Can you represent that? There are 5 red cars and there are 3 blue cars.
We don't have any blue cars. We have yellow.
Well, can we use a yellow counter to represent a blue car?
Yeah.
Are you sure?
Yeah. It doesn't matter which colour it is.
Oh, it doesn't, Miley, does it? Some of you have represented them mixed up, like this. And some of you have done a representation that I'm going to ask you all to move to. It's the representation that Harper and Nello have done, which is like this. So could you all please make that representation for our 5 red cars and our 3 blue cars, just like Harper and Nello have done? Although they've done a range of different representations, the representation I wanted to pull them towards was 5 counters with 3 counters underneath. OK, and everyone look to the front. So here is our representation. What do the 5 red counters represent? Ollie?
There are 5 red cars.
And who can tell me what the 3 blue counters represent? Can you use a whole sentence to say that? It's the 3 blue counters.
3 blue counters represent the 3 blue cars.
Now, on this table, we didn't have blue counters, so they've used yellow counters. And did it matter?
No.
No. So looking at this picture, what is the difference between the number of red cars and the number of blue cars? Tell the person next to you. How many more red cars? What is the difference? Tell the person next to you.
Red cars and the difference of blue cars is 2. The difference between 5 and 3 is 2. There's 2 more red cars because 3 is a smaller number than 5. So we have 3 in here and 3 up here, and we add more 2 on, and then it makes a knobbly there, 2 more.
What's the difference between the number of blue counters and the number of red counters? The number of blue cars and the number of red cars. Rayan?
2 because 3 is 2 less than 5 and 5 is 2 more than 3.
Really lovely explaining. Looking at our diagram, we have 5 red cars and we have 3 blue cars. And you have all discussed, and Rayhan's told us, that the difference is 2. There are 2 more red cars than blue cars. I'd like you to look really carefully now at what I'm going to do. There's my 5 red cars. There's my 3 blue cars. And there is my difference of 2. Keep looking at that. The children are really familiar with using the part-part-whole model, and I wanted to use what they know about the part-part-whole model to show them that it can be used for comparison of 2 sets and thinking about the difference in value between those sets. Keep looking at that. Does that look at all familiar? Keep having a look at that. What have you noticed? Who can tell me what you've noticed? Ismay, what have you noticed about that diagram?
It's a part-part-whole square.
It's a part-part-whole. We can use part-part-whole to tell us about difference. Can we all say that? We can use part-part-whole to tell us about difference. Hannah and Freddie, let's all say it together. We can understanding that difference is a form of subtraction. That will be a STEM sentence that they will say again and again. The difference between 5 and 3 is 2. The difference between 5 and 3 is 2. 5 subtract 3 is 2. I've got another one for you to represent now, and then you're going to be doing some in your book. There are 7 children and there are 4 dinner tokens. Can you represent that? Off you go.
1, I've already got 7. 5, 6, 7. I've already got 7. So do
7 children. So, can you represent that, Joe? We've got 7 children and 4 dinner tickets. How many counters have we got here at the moment?
7.
Let's have a check. 1, 2, 3, 4, 5. So can you add some counters? So we've got 7 children. Oh, Joe's got 2, great.
I'll wait for these yellow 4.
And Oscar, can you represent the 4 dinner tokens, please? Are there going to be enough dinner tokens for all the children?
No.
I wonder if we can think about how many children aren't going to have dinner tokens.
3.
3. So 3 is the difference. There is a difference of 3. Now you've made 5 dinner tokens, but in my story I'd like there to be 4 dinner tokens so we can all think about the same number, Joe.
Miss Christie, 3 of them might be having packed lunch.
So the 7 blue counters, what do they represent?
They represent the people.
Good, the 7 children. And the 4 red counters represent what?
The dinner tickets.
Are there enough dinner tickets for everyone?
No.
What is the difference between the number of children and the number of dinner tickets, Ismay?
3 is the difference between 7 and 4.
Good girl, it is. And I would like you all to now represent that on a part whole. Show me that 3 is the difference between 7 and 4. So pen back to the other person. And can you change this into a part whole, please?
Hurry up. The biggest number is 7. There are 7 children, and there are 4 dinner tokens, and 3 children are having packed lunch. The difference between this is 3, and then between 4 and 7 is 3.
So we're using our part whole to compare the 7 and 4. So can you draw the part whole for me? Well done. So we're comparing 7 and 4. Can you show me that in your part whole? That we're comparing a 7 and a 4. Okay, you've done something really sensible that we've done a lot with part whole. We've used it to add things together. Just have a little look at the board, because this time we're not using it to add together, we're using it to compare the 7 and the 4. Okay, so let's have a look. I'm going to turn this into a part whole. Instead, we'll draw around this. Can I get rid of that? So, we're going to use it to compare our children and our dinner tokens. How many children do I have?
7.
Good. So you take the pen. Can you write that in part whole for me? And write it up here where we've just taken the counters away. Good. And how many dinner tokens?
4.
Good boy. And what's the difference? What's the difference between the number of children and the number of dinner tokens? Have a look.
3 more.
There are 3 more. Well done. Fantastic. How could you work out that 3 goes here if you've got 7 is your whole and 1 part's your 4? How could you work out your other part is 3?
3 and 4.
You know that 3 and 4 make 7. Fantastic.
Yay! The 4 means the 4 dinner tokens, and the 3 means the people that don't have.
So I just wanted to pick up because a couple of people have represented your 7 and your 4 in your part whole like that. And we've used our part whole a lot to add things together. But today we're learning a different way to use our part whole. We're learning how to compare with our part whole. So I think most of you got to the stage where you knew you had to compare 7 and 4. What I would like you to tell me is what is the difference between 7 and 4 that I'm going to write in my part whole, and how did you know? How could I work it out? Chloe, what's the difference between 7 and 4 and how could I work it out?
Because you could see there was 3 more that didn't have a red token underneath it.
Fantastic. I could just see by looking at it. Who can tell me how we would know, even without the counters? How would you know what number goes in here? What number goes in here?
If you knew that 4 and 3 would make 7, then you would know that it would be 3.
That's right. What Ollie's said is that 3 add 4 equals 7.
Yeah.
And we could use that addition fact to help us find the missing part, to help us find the difference.